And we come to the last talk of this session, and it's Pallavi, Aras and Shumon Huque from Salesforce. And welcome to the stage.
Hi, I'm Pallavi, Aras. This thing went blank on me. I'm Pallavi, Aras. With me I have Shumon Huque. We are kind of going to, this is the last presentation, so bear with us. We are going to give you a glimpse into some of the authoritative traffic data that we have seen and just go over some of that analysis. So the goal of today's presentation is we are going to take the traffic data, analyze that data, and we are going to come up with some actionable insights, some traffic trends, and characterization of that traffic. So the data, the source of this analysis, the source of the data source for this analysis is basically raw query data that is captured by our DNS provider over an extended period of time. And what we have done is we have taken that data and we have analyzed it using Anthropic Claude, bear with us, LLM. We have the reason why we wanted to use Claude, and you can see with the amount of queries that we have, we use that to give a sort of a direction, correlation between data and insights, which we can then further develop on. So actionable insights. One of the first analysis we did was NXDOMAIN analysis. What we found was looking at all the data, our email infra domain did not get as much of query. The amount of queries it received was less, but still it had the highest amount of NXDOMAIN responses. So why is that? We wanted to sort of analyze this. And this NXDOMAIN stayed consistent month over month for the time period that we looked into it. And I think I don't know if you are able to read it, but a pattern emerged, right? We saw that the NX domain, whether it's pattern-based or IP-based, the NX domain fell into two major categories, and both these categories were linked to the exist clause in the SPF record for our critical domain. So what is the cause of getting so much NX domain related to the exist clause? Could it be misconfiguration from the querier side? Could it be some sort of recon? We don't know. That's something we have to look into. So our next steps would be to work with the email infra teams who actually manage the records within these zones, talk to the security teams, figure out, show them this data, discuss this with them to understand what can be done with this data and how it will be useful to them. I have a lot of slides. I'm going to go through them pretty fast. The zones that I'm having in my slides are not the real zone names. I cannot use the real zone names. We have to get these talks approved. So these are fake names. Bear with me when I use fake names, but you can get an idea. So the geographic distribution of the DNS queries, we wanted to sort of get an idea of who is querying us from where. So if you look at this data, you can see that our largest amount of queries come from North America, and all of those queries are sort of answered by the Washington, D.C. Edge node of our provider. Not much of a surprise there. But how are we going to use this data? That's the main question. Another thing that we observed was the IPv6 adoption in EU North was far more than what we saw in Asia. Again, what are we going to do with this data, right? So this data, what we are going to do is sort of give it to the internal teams that manage capacity so that they understand, hey, we have to beef up capacity maybe in America, certain regions, certain areas versus other areas. If teams are trying to figure out where IPv6 deployment will buy them more value, this data will be useful for them. This next analysis is sort of similar but a little bit a different take, where we have done country-based analysis for query distribution for a few of our zones. And in this case, we considered queries with EDNS, EDNS client subnet, and queries without, right? The queries that come without client subnet, we have looked at the resolver IPs. So if you look at these numbers, just bear with these numbers. But basically what we saw was if queries are considered with EDNS, our live chat zone, which is used by our customers, became the higher queried zone. Why? We have to figure that out. And then there is a certain set of countries that are top 5 countries in terms of query volume. But if you look at the queries that we got without ECS, without client subnet, the query volume is much more. If you see the previous slides, the query volume we got with ECS is much lesser. Query volume is much higher without ECS. But now the most queried zone changed. It is now our login or our auth zone, which is the most queried zone. And the top 5 countries have also changed. Why is that? So these main zone and all of that you see are fake names. We had to camouflage some of the names. But this kind of brings up thing that if ECS is used, if ECS is not considered, the most queried zone changes. So this is some of the information we can provide to our internal application teams who might be depending on ECS to manage the latency and all for their own customers, right? So this is good information, good data that we can share with them. This is the last piece of insights, and before I hand off to Shumon. So that we wanted to also figure out what are the top talking clients for our zones, or these are our main application zones. So what are the top talking clients for our zones? Again, we took data with ECS, without ECS, right? So the number of queries that we get with ECS are far, far lesser than number of queries that we get without ECS. So we found some names, some sort of unexpected names that kind of were high when we saw queries with ECS. So that's something that is interesting to see this. We saw high concentration of traffic from some of these providers per subnet. So that was another interesting piece of data. Month over month increase in certain clients, that was another interesting data. But now that we look at clients without ECS, the number of queries are very, very high. And now a different set of customers come as the top queryers. We also saw a lot of high concentration of queries per IP from some of our internal networks. So that is an interesting piece of data. We saw a lot of high queries from CDN networks. Basically, what we want to do is now share this information with some of our infrastructure teams to see if some better caching strategies on those queryers can help reduce the query volume that some of our providers are seeing. So basically, the whole insight section is for us to take this query data, analyze it, come up with some initial pieces of information, and then share it with teams to see if they can make use of this data for better decision making. Now I'll hand it off to Shumon Huque to talk about traffic trends and characterization. Thank you.
All right, thanks, Pallavi. So let me warn you beforehand that I didn't follow the rules, so some of my slides actually name real zones. So I'll deal with that. Okay, so first I wanted to look at query type distribution. over a period of time. So as you might imagine, A dominates, followed by Quad A, which is about 40% of A, dual stack clients and whatnot. And further down, we have HTTPS, which is way lower, but definitely clearly visible. And then we have NS, which is probably things like resolvers doing NS revalidation or some implementations of QNAME minimization. And CNAME and MX are also popular. Here is a tabular view where we can explore more of the tail end of the distribution, and you'll see lots of other interesting query types that appear, including things that you normally wouldn't be expected to query very often, things like RRSig or even NSEC3, which is not really designed to be queried at all, but they show up. And we also have several long obsoleted query types like SPF and a few others, which I'm going to go into next. So this graph is a little bit misleading. You have to look at the left and right axis. So SPF dimensions are on the left axis, and SPF actually is significantly more than A6 and DLV. So SPF was, let's see, it was deprecated in 2014, so that was 12 years ago. A6 was deprecated in 2012, even further away. And DLV, the ISC DLV service at least, was shut down in 2017. But as probably most people in this room know, old stuff in the DNS never, ever goes away, right? So the good thing, though, is if you look, there is clearly a downward trend, at least for SPF and A6. All right, so in the next chart, what I'm going to show you is a study that we did to see if there was a correlation between truncated UDP responses and TCP responses. And from this graph, as you can clearly see, there is a almost precise correlation. And the correlation followed even that giant spike. There's a particular interesting reason for the spike, which I'm not going to go into. You can ask me later. But the correlation followed that spike all the way up there, too. There is some deviation. If you look at the graph, there are periods of time where TCP exceeded UDP. We don't really know what the reason for that is. Maybe TCP first or TCP only clients. There may be a smattering of that. It would be a little bit more concerning for us if the deviation was in the other direction, which may indicate that there are some fraction of clients that are not properly failing over to TCP, but we're not seeing that in the data, at least for our traffic. And I'll skip over this slide. This is for the statistics geeks. We did the Pearson correlation coefficient. And response codes, Pallavi, you did that already, so I'm just going to skip over this again in the interest of time. And let's go to resolvers setting the DNS-OARC OK flag. So as you can see, this is for the Salesforce.com zone, and it goes up and down, but it's between very close to 90%. Of course, from this data, we can only ascertain resolvers that are DNS-OARC aware, not necessarily DNS-OARC validating. That requires a more complex active measurement, but I think it's still a pretty positive sign that the percentage is so high. If we look at the overall, so this graph, what it shows you is for the queries that did send the DNS-OARC OK flag, how many of the responses came back with actually signed data. So as you can see, it's between 50 and 60%. This is more or less a reflection of the proportion of our zones that are signed versus unsigned and the relative queries into them, which is not surprising because we know we haven't signed all of our zones. If you did filter out the data and look at zones that are signed, so the line at the top, you can see the percentage is going to be almost 100%, right? Okay, so then we look at newer record types. As you saw from the query type distribution, there is a non-trivial amount of HTTPS query traffic going on. If we look at the Salesforce.com zone, one interesting aspect that we noted is there is a distinctive downward trend over the 9 months that we did this measurement, We don't really know why. I'd be interested if anyone has any reasons for that. Our speculation is that maybe there's a maturing software ecosystem that is more efficient, or is caching the results of HTTPS queries, something like that, but that was interesting. And the other thing we wanted to determine is the relative uptake of HTTPS amongst resolvers. Web browsers at least, clients. And we can do this the hard way by looking at the raw query data. That takes a lot of time. But to do it the quicker way, what we did was just use the ratio of HTTPS to A queries as a proxy. And if we look at that number, you'll see it's between 3 and 8%, means that HTTPS is still in a fledgling period of adoption, which is not surprising, and it has some ways to go. Here is a breakdown of that ratio by resolver geography, which I'm also going to skip over, and go to a breakdown by client IP versus ECS. Here there is a distinctive difference. The number is much higher for ECS sending resolvers. And the reason for that, I think, is that there is a much higher proportion of consumer-grade browsers that are customers of those kind of public resolvers that commonly send ECS traffic. That's why you're probably seeing that difference. And on the topic of ECS, some observations are that only a small percentage of the observed traffic that we see actually sends the ECS client subnet option. And only a small proportion of the resolvers actually send ECS, so 5.4%. And that volumes primarily come from IP addresses that are associated with big public resolvers. Some of them send the option unconditionally. Some of them send it selectively. There are many other things we've done with the data. So we've looked at essentially inactive zones. How we identified them are zones with very few queries, or queries that are almost exclusively composed of either NXDOMAIN or erroneous response code. And we've used that to identify zones in our portfolio that probably should be retired or decommissioned. And let me switch gears a little bit to talk about the data collection architecture. So Pallavi didn't mention it, but the vendor that we're working with is Authoritative DNS. So I think Steve de Jong is somewhere in the audience. Where he is? There he is. So I'm going to describe what they have is a data lake architecture that allows us to have access to this kind of data to do this kind of analysis. I'm going to walk you at a high level through their architecture. If you have any detailed questions, you know who to talk to. So what they do is all of their edge name server nodes, they collect all the raw DNS traffic data. They push it into storage in AWS, and they parse the packets. They enrich the packets with additional metadata tagging. This is things like geolocation and autonomous system numbers. And then they have another pass where they do a series of time-based aggregation on various indices like answering node, account. We have many accounts of these providers, zones, etc. And then they extract customer-specific data and push those out to customer-specific S3 buckets. And the interface of the customer is essentially through Amazon's Athena, which, if you're not familiar, is a serverless SQL engine. All right, so some of the analyses that we wanted to perform but were unable to were due to some limitations of the data collection architecture. So things like what we wanted to do a more precise investigation of truncation and retry behavior was to examine the client's advertised EDNS buffer size. So this is not available today. Things like we wanted to look at the full range of possible EDNS header flags and EDNS options. Again, all of this was not available. What they do today is very selectively extract only the commonly used things. So things like the DNS-OK header flag and the ECS subnet option. Response size is also not available, and they only capture data for 53 TCP and 53 UDP. So one of the things we wanted to do was to, back to Sarah Dickinson's talk, to see what quantity of probing of secure transports there is. We weren't able to do that. So we are in discussions with Ultra DNS about seeing if in the future they can close some of these visibility gaps and do better. So we'll see how that goes. And let's see, how much time do I have? So general comments. So we have multiple DNS vendors, but we're only looking at one, but we suspect that if you do this data collection on a broad enough scale, there will be broad similarities in the traffic profiles. So these are profiles that are peculiar to our enterprise DNS infrastructure. We don't know how representative they are of other enterprise or SaaS providers. We would be very interested if anyone else has done similar traffic profiles to see if we can do a comparison. We do know that there are some aspects of our measurements that distinctly diverge from other types of authoritative DNS services like the root servers and the TLDs, which of course have a much higher rate of NX domains, for example. Getting to the end, I think this type of data lake capability is fairly unique amongst DNS providers. Most vendors offer some sort of near real-time query logging capability, but they're very limited in the number of fields that they expose, and there are challenges doing this on a large scale because of storage and cost considerations. But we think this is a good capability in general to have. And my last pitch is, I would like to see this as a common offering amongst managed DNS providers. We use a lot of them, and it would be good to have some feature parity across them. And this type of data unlocks many different capabilities. So you can do much more sophisticated traffic characterization and trending. You can do security analysis and response, research, all sorts of other things. And finally, I'm going to end with a shout out to Steve DeYoung and Chester Hockersmith of DigiCert Ultra DNS, who helped us dig into a lot of details of this system and answer many questions from us. With that, I will stop and see if there are any questions. And Pallavi will answer all the questions for you.
Sorry. We have 2 minutes for questions. So,
Casey DCO, BYU. So a couple questions. Number one, you're comparing a lot of query types.
Yep.
And that's one way of looking at it. Another way of looking at it, not just in terms of raw numbers, is to actually look at, for example, if you have, let's say your A record has a time to live value of 5 seconds, and your quad A record has a time to live of, some much longer time,
Sure.
then you may be getting some sort of weird things. And so when you're comparing those things, that may be something you consider is how to normalize those somehow.
Yep.
And that includes things that don't exist, and so that for which you would get the minimum time to live value would come into play. And then I did see, you mentioned that, sorry, I'll make it quick. You did mention that your UDP truncated versus TCP. You said, well, we didn't see the one version, but on the graph it actually did look like the one was higher than the other in a lot of cases, and then they sort of swapped. But maybe it's just hard to tell from the plot. But
Sure.
anyway.
Yeah, we can talk about it. There is a little bit of variance, definitely. It's not completely one-to-one. Yep.
Right. Thanks for the talk, Giovanni, Modus, IDN, and Theo Delft. Shumon, I want to know a little bit more about Ultra DNS kind of clients. Which kind of client population we're talking about here? Like it's business.
Could you come to the mic a little bit closer?
Sorry.
Yep.
Is it better now?
Yep.
Yeah. Now, I would like to know a little bit more of how generic how much you can generalize your results based on the client population that you have.
Right.
Because I think Ultra DNS is primarily business clients that come to them, right?
Yep.
And have you looked into other studies that compare this to, I don't know, the roots or any other, public services that are not business-like?
Yeah, so I don't know. I haven't looked into it. So I mean, that's one of the questions I posed, right? So it would be good to look at other types of DNS customers and whether their traffic profiles are similar to ours or radically different. I have no idea.
All right,
Yep.
thanks.
I had one point to add to that question. So if you see some of the data that is on one of the analysis, what we saw was the number of unique IPs that we saw was pretty high. So it is not just business. So some of the data that comes to us is not just businesses like our B2B businesses, but end customers also, their own end customers. So there was a very high percentage of unique IPs that we saw.
Hi, Thijs van den Hout, also SIDN Labs. I just want to make a quick comment. A couple of years ago, or quite many years ago, we developed Entrada, which is an authoritative DNS data lake solution, and it's open source. So it also does this PCAP to Parquet to queryable
Yep.
insights.
Yeah, thanks. I'm familiar with Entrada. So I built some of these systems before when I ran all my own DNS servers, right? So the challenge we have right now is we mostly used commercial managed DNS providers, and we want them to build these kind of systems, right? So
Or
if
use
you
it.
can market Entrada to one of those guys,
Yeah,
that'd be great.
Thanks.
Okay, thank you,
Yep.
Pallavi. Thank you, Shumon.
Thanks.